So we're going to talk a little bit more about water quality problems. Sorry if I'm a little teary. I just found out one of our NIU Huskies is homeless right now because of everything going on, and I'm like, must fix this, must help them. So, just makes me cry. So, sorry. So arsenic contamination. So this is a major problem in this part of the country due to natural phenomenon. So the World Health Organization recommends that the maximum in drinking water be about 10 parts per billion. So if we think about parts per billion, that is, like if we have 7 billion people on the planet, and you can find 7 is 1 part per billion, so this is 10 times that, so citing 70 people of all the people on the planet, so just to give you an idea. The EU recommends 50 parts per billion, so micrograms per liter is the same as parts per billion. Milligrams per liter is the same as parts per million, so this is 50 parts per billion. The United States government has ours set at 10. There has been actual studies that have shown down to 5 cause mental health problems with younger children, especially if they're drinking arsenic. There is no safe levels of arsenic, basically. We don't need it. It's not safe for us to drink. There is no reason to have arsenic in our water. But it's hard to detect, and it is naturally occurring. So that's part of the problem. So we can detect it using these little kits, like if we're in the field. So as I go around the world and I'm doing work on things, we can do this. We can also detect it using very expensive pieces of equipment that take long periods of time to detect, called an ICP-MS. Or you can use these test kits. So this is a major problem around the world. So this is a groundwater contamination. I worked on a project in Mexico before about this, in the central part of Mexico, related to arsenic and fluoride inside of their water. Myanmar, there's problems in that. I'll talk a little bit about Bangladesh because that's an area. You can find it in areas where there's geothermal waters, such as Argentina, United States, and mining areas too. We have this in the southwestern United States, and I'll show you a map here. This shows the arsenic concentrations. Anything that's in this orange is above 10. Anything in red is above 50. Which used to be our old MCL. Now it's dropped down to 10, thank God. And we had it higher because it's hard to remove from water. We'll talk a little bit about how you remove it, but it was hard to remove. But we lowered it during the Clinton administration from 50 down to 10 parts per million. So you can see this is a major problem. Now, so this water magically stops at the Wisconsin line. See, Wisconsin has a major problem, but Illinois, we don't have... Oh, wait a second. That's political. So no, if you kind of look at this would be an issue here in the state of Illinois too. Same thing over here. Notice that there's like a line right here. These are political issues, not groundwater problems. So this extends across these borders. These are just issues associated with different states having different municipalities. Groundwater and contamination is not the smart to know where the boundaries of states are. So you can see Minnesota and Wisconsin do a lot of testing. There's some major problems up in here. Green Bay, Fond du Lac area up in there has it. And it goes down into the Fox River Valley and then downstate in the Mohammed Aquifer area. There's some arsenic issues associated with it. We got problems in Texas, San Joaquin Valley. We talked about groundwater pumping from there. This is some of the arsenic that's associated with it. One thing to keep in mind with arsenic is, especially since, this is where most of our food comes from, and they have arsenic problems that are high in their groundwater, not all plants absorb arsenic into their bodies. So plants are, each plant is different on how it deals with different metals inside of the water. Some of them shunt it, some take it up, some do it. So you can't just say because the water is associated with a plant that the plant is going to always take up that heavy metal. Different plants have different ways. So this does not mean all of our food is contaminated with arsenic inside of there. But there is arsenic problems all across the United States. Again, this is related to the geology. Now, there is a case, if we look at Arkansas, there was a problem. Well, they used to do this. They don't do it anymore, thank God. I used to give chickens some arsenic, and they would, if right near the while they were growing up, because it would irritate the back of their throat, and they would eat more and they would get bigger, and then they would switch them on to non-arsenic food near the end of their lives, so that it would be out of their systems when they get slaughtered. But that chicken litter, which is the poop from all the chickens, we call it chicken litter, was high in arsenic, and so there was some pollution problems, especially in Arkansas down in here, which is associated with chicken litter. Yeah, so we don't do that anymore, thank God. So arsenic cycles, it goes around. It's generally related to our redox conditions. So as we go from oxidizing, remember this is where oxygen is inside of the water, versus reducing. This is when we have too much organics. Remember, this is how we get coal and oil and everything being formed. We get those reducing conditions. We get arsenic mobile during reducing conditions, and then becoming a solid during aerobic conditions. So a lot of groundwater, especially in this area, is anaerobic because we have all this high organic soils around here, the black soils. So as water goes through it, it uses up all the oxygen, so we generally have anaerobic groundwater in the area. And so it moves the arsenic around. It gets into our drinking water supply, and so we can get an arsenic cycling. So arsenic chemistry. Arsenic has a couple oxidation states. So we find arsenic associated with sulfide minerals. We can find it as a metal. Generally, we have arsenic 3 and arsenic 5. Arsenic can be removed from mine water by the addition of iron sulfate. So we can add things into it. The iron then precipitates this out. And then we can oxidize arsenic 3 to less toxic arsenic 5 to slow down its movement into oxidizing environments. So one of the good things about knowing about chemistry, and if you're really interested in all of this, my other class I teach, which is environmental geochemistry, I go a lot into arsenic. We spend like almost a whole month, couple weeks, 3 weeks on arsenic, and really go in depth into this chemistry that's in here, how this works, why does it work, how do we fix it, everything associated with it. This class, I'm just going to kind of give you some basics of it. So we have the arsenate and arsenite, and so these are the two common species of it. So the trivalent is the arsenite, is over here, so that's arsenic 3, and then the pentavalent over here is arsenic 5. And so these are the two species that we have inside of groundwater, and they move depending on the oxidation system of the soil. So here right now we can look at, so we have the injection stop, so we have arsenite is most stable form of arsenic in reducing environments, and arsenate, which is less mobile than arsenite, is dominant in oxidizing in neutral pH environments. So arsenate, which is found in oxidizing environments, doesn't hardly move. It's very stable. It just kind of sits there. And then when we get anaerobic water or reducing environments, remember we talked about massive reducing environments. This is how we get methane being formed and stuff like that. That right there moves the system, and it's more stable. And so it moves and it just goes right into our drinking water supply. And arsenite is our arsenic 3, which is much more toxic than arsenic 5. So we're getting kind of a wham bam, thank you ma'am on that, and this is what's happening up in this area. This is especially a major problem up in this region where we have a lot of anaerobic water. The arsenic is found naturally in the soils, so it's not something that was dumped there, not like my chicken story down here, but this is all up in that area there. I'm going to talk a little bit here about a classic case of where arsenic was a major water quality problem around the world, and this is in Bangladesh. So Bangladesh, here's the country of Bangladesh. So hold on a second, I'm going to get a world map and show you where it is, and for people who are not 100% sure where we're talking. Okay, so a world map here. Okay, so here's Google Earth, and here's India, China, Myanmar, where I was. Here's Bangladesh. So just so you guys have an idea of Bangladesh. Zoom in a little bit. So what's happening here in Bangladesh is you have the river systems that go right through the major part of the country. They come here from the Himalayas, or the Himalayas, as a lot of geologists pronounce. So if you guys remember, when we talked about plate tectonics, India was one of the fastest moving plates in the world. It sets a world record. It went so fast, it bumped into this plate over here, it caused the forming of the Himalayan mountain range. Well, this has a lot of arsenic inside of it, and so as this weathers away, these rivers that are found up in this area, this water then flows down through these mountains down into this area down here, into this bay area here. So remember when we talked about, you know, stuff coming down rivers and dumping and stuff like that? So this is all the bay area down here. It's a deltaic region in this area. And so this is all these sediments that were dropped off into here, bring stuff from the rivers that are further up north and bring it down from the Himalayas down into this region. So this is the region that we're talking about here. So here again, here's our Bangladesh, India. This is the concentrations. So anything that is wells that are, this is percentage that exceed that 50 parts per billion. So if we remember, our U.S. limit is 10, World Health Organization, we really want to keep it less than 10, but these are set at 50. This is the old standard, but this is still a World Health Organization standard in there. And so you can see numbers of wells between 70 and 100 exceeding the levels of arsenic, exceeding that level. We have areas that are okay, and then we've got these areas that are just hot spots for the amount of arsenic that's inside of the groundwater. So what happened here in Bangladesh was that people of these areas were all drinking surface water. So surface water can be considered, you know, would have a lot of bacteria into it. They were having chronic cholera epidemics, diarrhea. I mean, you've got all of the pollution that was coming again from upstream, getting dumped into this area. People were really sick. There was a lot of pathogens going on. And so one of the quickest ways to help a population if they're having problems with their drinking water supply is to move them to groundwater. So you can put in these tube wells, and so we're calling them tube wells. It's just the wells that we've been talking about. You put these shallow wells in, and then people drink that, and it improves their water quality because, as we've already talked about, as the water goes through there, it removes a lot of the contaminants inside of there. So this is a very first step of how to improve health especially in low-income countries, is by providing them with groundwater instead of using the local surface water. Well, the problem with that is that all of a sudden they started drinking all this groundwater, and they started getting massively sick from it because they were getting arsenic poisoning. So what does arsenic poisoning look like? This is what it looks like. So this is a Bangladeshi woman. The symptoms of arsenic poisoning. So what this was is we just exposed them all to this massive amounts of arsenic inside of there. People started getting sick with skin lesions, black skin, eventually cancer. They were shunned by others because they thought it was contagious, and it's not contagious. It's just from their drinking water. Men and children were more affected than women. I don't know why, but they were. And then Bangladesh is about 20% of the wells were contaminated, and approximately 80 million people depended on it, were exposed to this. So this is a very bad region when it comes to this. High levels of arsenic because of them trying to drink water. So what they did was, one of the things that they did was the solutions to this I'll come back to that. Okay, so what was the sources of it? As I said, these are the arsenic-rich sulfide deposits in the Himalayas, and the arsenic-rich sediments continued down the Ganges Delta, so this is all coming from the Himalayas. It got mobilized into well water because of the aerobic and anaerobic systems. Where the wells were put in caused it, the different minerals that were there, and because this is a deltaic region, you get these deltas, these water flows down the system, and then you get this very layer cake system because, like, you'll get flushes due to different rain events that occur in there. And so because of that, you'll get different types of water inside of those systems. And so it was causing a lot of problems, and you've got a lot of iron that's associated with it. And so we were having a lot of problems with the arsenic problems. So what were some of their solutions to this? Well, one of the things they did was they went through each particular well, tested it, and then painted them red or green to say if you can drink it or not. If it was red, it could be used for bathing, it could be used for washing your dishes and stuff. Green was associated with it's being cleaned. So it was one way to immediately go through a town and find the good wells and the good areas in there. We educated people about the illnesses that were going in there. They did drill some deeper wells so that people could still have to walk and get their water, but maybe they were in there. It was really hard to change and get the effects of this from from people. So one of the other things that happened was that I thought was interesting with the story here was that eventually, because we didn't, so the community, the people who were working in there didn't educate the locals enough. They just kind of said red bad, green good. They didn't explain to them that the water inside of the wells was what was bad. So when the red paint started to chip off of it, they thought it was the paint on the outside that made this well bad. So once the red paint started to chip off, they started drinking it again because they're like, oh, what was bad, red is bad, the red is gone, so it must be fine now. And so they had to go back in there and close off some of the wells and go through and educate people about how arsenic is a bad problem inside of there. So this is so one other little thing I was going to point out with issues here in the States. A lot of times these are rural water quality problems, especially up in Wisconsin. So an interesting side effect of all this is if you know something is wrong with your water, okay, you've got groundwater issues, you've got something wrong with your home and you try to sell your home, you have to disclose it to the next person, okay? So if you have your water tested and you find out you have high arsenic, you have to let the next person know who's buying your house, I have arsenic. And in rural water, no water has to be tested. Water does not have to be tested if you own your own well. Okay, that's no law that says you have to test. It's a good idea to do it, but you don't have to do the water quality. You don't have to do testing of it. So sometimes people don't want to know if there's water problems in their home because then they have to disclose it and then they have to put in a treatment system or they may not be able to sell their home. So sometimes people will be drinking this or not want to know about it because of these issues associated with, with arsenic inside of their water supplies. They want to blame somebody, but it's just the geology of the area, and so it's a really interesting. So what do you do? For broke water. So this is a problem of central and up into Wisconsin, major problem. So, okay, bye.